Hello, hello, my wonderful students from all across the county, all the way from Apopka to Cypress Creek to wherever you are right now. You need help with composition of functions, this is the video for you, all right? So I get a lot of questions, like a lot of questions on, Miss, I have no idea what this is. I don't know how to do it. I don't get it. I don't know what goes first. I don't know how they got this answer. I get it. Take a breather. You're not the only one. That's why I'm making this video. Okay. So composition of functions, it's a weird concept because it's not the way we usually think of math. Usually when you're doing math, you have you have a direction and way to do it. Composition of functions, we work a little backwards, and that's why it's a little weird. Okay. So what I want you to look at right now is if you need these basic rules just for your own benefit to kind of give you a guideline on what we're doing, I want you to pause this video right now and just jot down just that top part, not the bottom. If you know me, if you've spoken to me before, you know that I do not like words in math, okay? I ask you to turn in your work for your chapter review, your notes, whatever it is. I don't want to see the words that you write. I want to see the work on that problem. That's how I know you understand what you're doing, okay? Especially when it comes to things like this. Now, if you want, you can pause it. I'm going to move on. I'm going to show you a few problems and how I get it done with the composition of functions. And you should be able to kind of do it a little bit easier. We're going to first go over some basic concepts of how it actually just go about, combining like terms and just a little bit of pre-algebra and algebra 1 in there. And then we're going to go more into algebra 2. So if you're in algebra 1 and you're doing some, combining like factors, we could definitely use this video. If you're trying to just do a composition of function question real quick, also pay attention to your pre-order. So pause it if you need it. I'm moving on. Okay, so this is a general adding and subtracting question with composition of functions, okay? So here, we're not actually doing a proper composition of functions because it's not asking us to put anything in there. What it's doing, and remember, when I say composition of functions, I don't want you to remember all those rules, okay? If you see composition of functions on your SAT, on your ACT, whatever it is, all you need to remember is do the second one first. Remember Miss K's word, do the second one first, all right? So what does that mean? Now, what it's saying is we have an f of x here, right? This entire thing here is f of x. And I'm going to change my color here. I make g of x is this entire thing, okay? And what it's asking you to do is f plus g with the composition of x. Now, we don't have a value here for x. So basically all we're doing is they're telling us to plug the x into the g. Well, sorry, second one first. We're going to plug the x into the g, meaning everywhere you see an x in the g of x, you're going to plug in an x. What does that mean? You're not changing anything. It's everywhere you see an x, you're plugging in an x. In this type of problem, because they don't have a value here, you're not changing it. All you're doing is doing whatever it's telling you to do inside of that front part right here, okay? So for instance, we have an f of x, which is 4x plus 7, and then we have a g of x, which is, remember there's a plus or minus sign in the front, so there's gonna be a positive square root of x plus x. Combine like terms, let's make that yellow. I know I'm going a little bit fast, but this is not the idea or the main concept that I'm trying to get to. This is just a quick review, just in case you forgot how to do this, okay? Where's my mouse? That's what happens when you do yellow, you lose your mouse. All right, so we do combining like terms. We have 5x. Nothing looks like this, nothing looks like this, so we leave it completely alone, okay? Now, it's the same concept with subtracting. All right, all you're going to do is you're doing f minus g. So now we have 4x plus 7. I'm going to add it up there because I don't think it'll take that much. Minus g. So we got to do a subtraction on this entire thing. Make sure to distribute that negative sign. Negative square root of x minus x. Don't forget that, okay? When it's telling you that negative, it's going to mess with you. That's the reason it's there. They want to make sure that my brilliant students, whoever you are, is not going to forget that negative, okay? So we have a 4x here, and we have a minus x here, all right? So what do we have now? 3x. minus the square root of x plus 7. All right, that's your answer for the negatives. That's your answer for the positives. It's not that hard right now because it's just going through the order of operations. Let's get more into that composition of functions where we get it. If you need it a little bit nicer, it's a little bit nicer here. You want to pause it, you want to check it, whatever you want to do, go ahead and do it for that. Okay, you want to pause it, you want to, look at it nicely. Maybe you don't like my handwriting. I don't know, whatever you want. All right. Okay, so multiplying and dividing. Exact same concept because it's not, you know what, I'm not even going to go through this because it's the exact same concept that we had for the adding and subtracting. Let me do the multiplication just in case. All right, so we have an f of x equals x squared minus 9, and we have a g of x equals x plus 3. Okay, it's not asking you for a composition of functions. They will trick you like that sometimes. It's just asking you to subtract and multiply them. Good concept actually just to, practice. X plus 3. Now, I'm happy I did this problem. This is a binomial times a binomial. A lot of my students do this, and I don't know why. Whenever we look at binomials, you gotta really quickly think in your head. You gotta think FOIL. FOIL, FOIL, FOIL. First, outer, inner, last, okay? You have to do it, otherwise you'll mess up and it'll get the wrong. See, if I was you sometimes, I remember when I was younger, I would do, x cubed minus 27 as my answer. How did I do that? X squared times x cubed, negative 9 times 3, negative 27. Don't make that mistake. You gotta do the FOIL procedure first, and it's also distributing. You see that? Outer, inner, last. It's a happy face, but we're distributing. You gotta make sure all the numbers are accounted for. All right, so let's really quickly, I'm just gonna do this on the bottom because this is not the concept I wanted to actually go to, but I think it's good to see how to actually do this. Negative 9x, and then the last one is going to be negative 27. Okay? What did I mess up? So x squared times x is x cubed. X squared times 3x is 3x squared. Negative 9 times x is negative 9x, and then minus 27. All right? Actually, I have no, I don't have anything that looks alike. I have nothing to combine. That is my answer. Okay? The division is the same concept. I'm not going to go through that one. Actually, extra credit if you do it and send it to me. Send it to me on an enrichment assessment. Now, sorry, just kidding. That's not an enrichment assessment. If you want to go ahead and do the other got it question on the bottom of that last slide, that'll be an enrichment assessment. Okay, now this is the part where I've been telling you, all right, the composition of functions. I'm happy we went through a couple of the examples to kind of remember how to add and subtract and multiply and divide these functions, but this is what I'm talking about, all right? So we have g to the, so we have g of f with the composition of negative 3. What did I say? Composition of functions in your head really quickly. Do the second one first, okay? What we're doing is we're making that negative 3 into the f first, okay? So remember in the last problem where we just had an x, what we were doing in our minds, you got to think of it the same way. You've got to put the x everywhere you see the x in the first equation. Remember? In this case, we have a value, which is that negative 3. So everywhere you see an x in the f, which is going to be this one, I'm going to make that purple, you got to add that negative 3 in there. So let me show you. So we have f of x equals, I got a student calling me. It's okay, I'll catch it later. Right, that's your f of x. So what we're gonna do is we're gonna do the second one first. We're gonna add that negative 3 everywhere you see an x in the f, okay? So we have negative 3 minus 5, okay? Which is gonna give you what? Negative 8, all right? Now, I have my new x. Now, once you do the second one first, now you got to take this answer, which is going to be my negative 8, and plug it into the g. Because that's your g unit. Just kidding. All right, cool. So what we're going to do now is take my answer, whatever we got here, and we're going to plug it into the g of x. So it's my original equation is x squared. So now I'm going to plug in negative 8 for my x, and my g of x is going to give me 64. That's how you do a composition of functions. I know it's so much harder when you're looking at it through the web. I don't know why they do it that way. Don't ask me, don't text me about it. I already know. That's how you do it, all right? Whatever's in the second one, you plug it into the first one, and then you just solve. All right. Did they give me two answers? No, they gave me, oh, they gave you two methods there. All right. I actually want to do a